So now our first expert is Dr. C.R. Chethan. It's my privilege to introduce Dr. C.R. Chethan. He is senior scientist at IARI Gogamukh, Assam, and earlier he was served at ICAR-Directorate of Weed Research, Jabalpur, where he has made the significant contribution in mechanization and precision weed management. Dr. Chethan obtained his PhD degree from IIT Kharagpur, and he has more than 9 years of research experience. His innovation have reduced the operational drudgery and enhanced the effective utilization of machinery for efficient weed control. Dr. Chethan has received many prestigious awards, including ISWS Young Weed Scientist Award and IEI Young Engineer Award, Young Scientist Expo TV Award, Best Worker Award from the ICAR-DWR Jabalpur. He has published more than 20 research papers, 5 reviews papers, and many more. So now I welcome sir, and we are honored to have him for today speak on the very important topic, smart technique on mechanized weed management. So Dr. Saab, now screen is yours, so you can start your talk.
Thank you, Doctor. Thank you. Before that, respected Director Sir, Dr. Ian Rao Sir, Geeta Madam, Ramesh Sir, Simajrit Madam, Choudhary Sir, Yogita Madam, all my seniors, organizers, and my friends. Good afternoon to one all. The brief introduction which already has been given. In this particular presentation, before that, I'll just share my presentation. Is my presentation visible?
Yes, it is. You can put in slideshow mode.
Okay. Is it in slideshow now?
Yeah, it's
okay. Thank you. In this presentation, I'm just briefly going to give what are some of the technologies which are available for the mechanized weed management. Some of the more technologies which are happening in India as well as the global. But mainly, I will talk about what are the main mechanized, some of the work which has been done in India from the perspective of Indian farmers. So I'm just going to be discussed here. Before that, by now, I think everybody knows that, what are the weeds and how it is having the detrimental effect on the crop and how much losses which is already which is going on. This is just the introductions, which is I'm not going to give you. I think I presume that, I think by now you people might have know that what is the weed and how much losses which is going. One particular point which I wanted to highlight here, some of the, after occurring the losses, farmers are using already some of the conventional and traditional weed management practices. But even then, the farmers are losing 15 to 16% of the yield. So it is because the inefficiency of the existing weed management practices, as well as they're totally depending from Indian farmers, they're totally depending upon the manual weeding as well as the conventional practices. Because of that, we are still using 15 to 16% of the crop yield losses. To overcome that, we have to go for the mechanized weed management. What is that? If you see the weed management practices, we have biological, cultural, and chemical and mechanical. But from the perspective point of mechanized weed management, if you see, there is one common thing is that. One common thing is that, so we are using the power, we are using the tools and equipment to perform the different kinds of operations in the different methodologies. Like we are using the tractors, we are using the plows, plastic mulcher layer, weeder, sprayer, aquatic weed harvester. One or the other machines in all the methodologies we are using and the kind of the power which we are using, it is the common. So increasing the availability of the farm power will automatically increase the mechanization level. So we have to do that, then only we could able to be effectively control the weed as well as the increase the profit. Before to that, we should understand what is the mechanized weed management. Mechanized weed management in the sense that we know that to perform any operations, we need power. To enhancing that availability of the power to perform any kind of operations or any kind of weed management practices to reduce the operator drudgery and also to increase the operational overall efficiency. That is called the mechanized weed management. It includes the starting from the, as I already shown, the tractor to the robots and drones and everything, power weeders, sprayers and everything will come. Wherever we use the power, so automatically this particular mechanization will come. If you see the status of weed management practices in India, India is a totally agriculture-based country and more than 49% of our population is totally involved with agriculture and allied sector, out of which more than 63% of the farmers are women labor only. They are totally engaged with these kinds of weeding, either weeding or sowing or agriculture-related operations. And if it is the per capita availability, we have very, very, very less. Like 1.08 hectare per head, which is average. But we have more than 86% of the farmers are small and marginal farmers. And if you see the average availability of the land holding, they have just, I think, around 0.8 hectare per small and marginal farmers. It is very, very less compared to the some developed nations as well as the other countries. So adopting the mechanized or adopting the advanced technology to this particular land as well as the farmers, it is very, very difficult. And we are facing the problem here. That is development of the different kinds of the advanced technology, adoption of the advanced technology. So we have to come up with some proper solution so that the mechanization level can be increased. And if you see in India, most of the weeding operations, which is totally done by the manual operations, which is very laborious and tedious job. And particularly these operations are performing either in sitting operations or bending or squatting operations. Because of that, we are consuming more than 30 to 50% of higher energy. Compared to the performing any operation in the standing position, it is very, very high. So we have to avoid particularly the manual weeding, and we have to come up with some kind of the mechanized operation. Then only we could able to reduce this kind of the drudgery. And if we see the total labor which is engaged for weed management, it is almost 25% of the total labor which is required for crop productions. We are going to be consumed for the weeding only. And if we see the mechanization level in India, the overall agricultural mechanization level, which is just only 47%, and we have only 3.045 of kilowatt of that much of power only to perform any operations. If we compare with some USA, Brazil, or some Russia and all, they have very huge amount of the farm power availability to perform any operations. But in India, because of the condition of economic condition of the farmer, fragmentation of the lands, or some topographical limitations, non-availability of the machines, we have very, very less mechanization. And if we come to the mechanization in weed management, it is even less. We have just only 33%. And if you see some of the major crops, in wheat, rice, and major cotton crop, somewhat it is okay. It is having 35 or 50% mechanization. But if we come to the sorghum or pulses and oilseed, it is very, even if it is 20% or less than 20%. So very, very less. In that particular conditions, we are just adopting the manual weed management practices. And if you just see the data here, for performing the weeding operations by manually, around 500 to 600 man-hour per hectare. It is very, very huge. If you compare the same amount with the power weeders, if you use instead of the manual weeding, just from 6 to 8 man-hour per hectare, we could able to perform the weeding operations. So there is a huge difference is there. There is a huge amount of labor investment is there as well as the cost investment is there. So we have to avoid the manual weeding and we have to come up with the mechanized weed management practices. These are some of the traditional, method of the conventional method of the weed management practices presently practiced in India. We use kudli, kurpi, sickle, locally made some hoes with some power weeders and all. But the problem is that adaptability of these kinds of machines to the local suitability, it is the big question mark. And these are some of the weeders which are available in the local market. But even then we have some research gap. The first research gap in the sense, why we are couldn't able to be adopt these kinds of advanced machinery at our Indian condition. First thing is that the lack of awareness of mechanical tools. Farmers doesn't know which type of the weeders which are available locally or otherwise whether they are available or not. That is the first big question mark. Second thing is that higher initial cost of the machine, even though machine is available to purchase, affordability of that particular machine to the Indian farmers, it is very, very difficult. For example, we have more than 86% of the farmers are small and marginal farmers, and if you see, they have less than 1 hectare of area, and their economical condition is very poor. And if I wanted to afford some mechanical weeder, advanced mechanical weeder, which is coming around minimum of 30 to 50,000 rupees in local market. To tell the farmer to adopt that kind of the weeders, it will become the problematic for him. Economically couldn't able to offer. So that is the one of the main reason which because of that couldn't able to be adopted at the farmers level. Then again, non-availability of the machine, fragmentation of the land. Because of the small land, we couldn't able to be adopt the bigger machines. Then requirement of highly skilled labor to operate that particular weeders. That is also one thing. Then our rural landscape and migration of laborers from the agriculture sector to the other sector. These are all some of the points which is hindering the adaptation of the highly mechanized weed management practices. This one study has been conducted in which they are clearly shown that how much of percentage of the farmers they have the opinion that on the different aspects. around 22% of the farmers, they are feeling that, it is very costly to afford. It is having high initial cost and it is very difficult to afford the machine. And around 20% of the farmers, they feel that hiring facilities is not there, skilled operator is not there. And compared to the advanced machineries, manual labors are cheaply available. So these kinds of the perceptions the farmers have, and they're lacking with the suitable technology. So we have to come up with some kind of a technology so that it can enhance the mechanization level at the small and marginal farmers levels. To do that, presently some of the work which is already happening in India, as well as the global level. So there are in the two ways the mechanization which is happening. First one is that is mechanization, some innovations and modifications which is making into the existing weeders and the sprayers. That is one thing. Another one is that integration of robotics, sensors, drones, and etc. That is another thing for site-specific management of the weed. The main objective of the both mechanization ways is that reduction of the operator treasury, increase the overall efficiency, and that precise management of weed as well as precise application of the input. That is the main motto of the both mechanization level. So these are all the some of the weeders which are locally available. We have different kinds of the power weeders like petrol engines or diesel engine operated. Some kind nowadays we are getting with the battery operated also. They are effectively can be used under different like dryland condition also as well as wetland condition. And but there is one problem is here that whenever we use these kinds of the machinery is that the person has to walk behind these weeders. Weeders in the, for example, if a weeder is having 30 centimeter width of cut and operator wants to perform the weeding operation for the entire 1 hectare area, he has to walk almost 33 to 35 kilometers per hectare. So it is very huge amount, so much of fatigue which is will come on to the operator. To reduce that, we have to come up with some kind of sitting arrangements to be like a tractor. We have to come up with some kinds of the mechanism so that this particular drudgery can be reduced. To do that, at our directorate, we try to develop some kind of low cost, ergo refined riding type weeders. In that one, it is having the proper clearance also to perform the different kinds of under different kinds of crop, as well as with the different spacing also. And one more thing is that whatever the existing weeders are there in locally available weeders are there, their minimum requirement for the width of cut is minimum is 30 centimeters. Even if it is less than 30 centimeter row spacing is there. So we see that there is a more, crop damage is there, which is beyond the recommended level. So adoption of those locally available, weeders, the narrow space crop, it is very, very difficult. In these particular conditions, we try to develop to try to solve this problem also. That is suitability of the weeders to the narrow space crop, as well as that is reduction of operator drudgery. Under this one, we try to develop, by using of a diesel engine and some kinds of some modifications to the existing weeders, we try to develop so that it can be used under, dry conditions under different crops with different spacing, starting from 20-25 centimeters to 30 centimeters. What we developed, it is able to operate more than 3 km per hour. It had very good weeding efficiency, more than 50%, with the field efficiency of more than 72%, and very good that field capacity. That is how much of the acreage which is covered per hectare. It has around almost 0.29, equal to the 0.3 hectare per hour. It could able to be covered, and very acceptable limit of crop damage it had. That is around 1.3%. And we could able to develop this particular weeder with a cost of around 35,000 rupees only. So our main motto was that is development of some kind of the weeder which could be able to be afforded by all categories of the farmers. And another thing is that, as I mentioned, that we have more than 86% of the farmers are small and marginal farmers. Adoption of the weeders which is having higher initial cost, it is very, very difficult. So we thought to come up with some solution so that the small and marginal farmers are also could able to be adopt these kind of the weeder. But we selected whatever the existing some popular manually operated weeders are there. We have selected that. Along with that, we selected one brush cutter weeder, which is coming around with a cost of 10 to 12,000 rupees only. So it is having the weeding attachment. We have selected that, and we have tested this one under the sweet corn as well as some other crops also. Under this one, we could able to be observe that brush cutter with weeding attachment performed very, very well. It had very low operational fatigue, which I expressed here. with the overall discomfort scoring. Discomfort scoring in the sense how much of the discomfort which I'm getting by performing the weeding operations by that particular tool. It is having very acceptable discomfort scoring. It had very high operational capacity. Here we could able to see that it had field capacity of 0.5 hectare per hour. If we compare this one with this whatever the hand weeding and with the other weeders, that the field capacity has been increased by 1,000-fold. So we could be able to see in the graph here, almost compared to hand weeding, that is 1,431 times it is higher, that field capacity, the efficiency which is higher compared to the hand weeding, and compared to the other weedings, it is more than 200. So it is very, very good, very suitable to the small and marginal farmers. It had weeding efficiency of more than 80% also, and requires just around 20 man-hour per hectare. That if we compare that particular value with others, weeders, hand weeding almost 500 to 600 per hectare. With other weeders, it is almost 63 to 50 to 63 man-hour per hectare. So compared to that, it is very, very less. And if you see the weeding efficiency as well as the number of the cobs and cob build we obtained almost at par the cob build as well as the number of cobs, green cobs we obtained. And with that, we also had the very good benefit cost ratio. So around 11. This one benefit cost ratios we obtained. By using of this one, we could able to say almost 93% of the labors we could able to see compared to the hand weeding, and compared to the other weedings also almost 80% of the we could able to see. So this is just a picture experiment where we have conducted. The first picture we could able to see that is a field which is performed by the brush cutter, and other fields which is performed by other weeders. And this is the field of the VD plot where weeds are there. And this is the cobs, the kind of the cobs which we obtained from the brush cutter operated field. And this is the operational by the brush cutter in the experiment plot. So very easily operator could able to be perform the weeding operations under different types of the crop also. It is very easily maneuverable and as well as very ergonomically recommended also. The same brush cutter with attachment could able to use under paddy condition also, that is wetland condition also, where it can be with some little modifications we can use it for the narrow spacing also. And this is just a specification which is recommended for the small and marginal farmers. The cost which is starting from even in the local market starts from the 8,000 rupees also, depending upon the power availability of the machine, and it goes up to 25,000 with some weeder attachments of 2,000 rupees to 2,500 rupees. It will come. By using of that one, the small and marginal farmers will effectively perform the weeding operations, mechanical weeding operations. But one more problem which we have observed that when in the black cotton soil and the sticky soil condition, when water is standing, then we don't have any problem. We can be able to use the weeders. But if it is water is not there and the soil is in sticky in nature, if I wanted to perform the weeding operations, it is very difficult because that stickiness of the soil automatically it will get clogged with the weeding element and it totally fail the mechanical weeding operations. If we wait for the optimum period for mechanical weeding operations, by that time there is an abundant growth of weeds will be there. Because of that, we couldn't able to perform the mechanical weeding operations. To overcome these problems, we try to develop some kind of rotating weeding element like structure by using of that one performing of the weeding operations. Initially, we try to develop with the manually operated weeders, and we have used under field condition also. If it is optimum moisture content, then it performs. If it is goes behind that, again this was getting clogged. To avoid that one, we come up with the power engine operated weeder we developed. What we did is here, instead of using the rotary blades, cutting blades like J type or L type, we just use nails type structure. That particular nail steel structure, because of that rotating action, that centrifugal force, whatever the soil stick onto that particular weeding element, because of the centrifugal force, automatically it will get self-clean without having any clog. Operations could able to be performed. We just developed this particular weed and it is under testing stage. Once it is approved, then it will come to the market. Then with addition to this particular works, we also try to develop the flame weeder. This we have developed for our experimental purpose. For one of our experimental part, we just developed by using the LPG cylinder, and we try to use it for perform the weeding operations. It was working very well. Condition is that the soil should have the optimum moisture content, as well as that stage of the crop, stage of the weed should be the initial stage, that is 3 to 4 leaf stage. If it is 3 to 4 leaf stage, then efficiency of that particular film wood was higher. If stage goes beyond, automatically that efficiency will get reduced. So we should be very careful while performing the film weeding. Then we try to develop some kind of self-propelled weeding element. In the sense, whatever the weeders we have, existing weeders we have, we need extra power we should give to the weeding element to perform the weeding operations. Here we did is that just using the forward motion of the track, rotating element will get rotate itself and perform the weeding operations. We try to develop that is self-propelling weeding element to perform the inter-row weeding operations, and we tested under the maize crop also. To 73%, more than 73% of the weeding efficiency we could able to be observed. It was also working very well, and it doesn't require any extra element. With a cost of 1,000 to 1,500 rupees, that particular element can be developed and can be effectively used. The condition is that it should have the proper row spacing. Then for the kitchen gardening purpose, we try to develop the battery operated, weeder by using up the battery, which can be easily weighed by the operator and can able to be perform the weeding operations. It is under the development stage. This is just the initial stage of the testing. We just developed and testing under testing stage. So it is working up to 4 centimeter depth of soil. It is working very well, but again, further fine tuning and development, final stage of development is remained, and it is under development, will come soon. We have tested this particular weeder for the economically suitability also, particularly concentrating the women farmers. So it is consuming very, very less oxygen, and the operations which is considered as very comfortable operation and can be easily wear and perform the weeding operations. It is best suitable to the kitchen gardening as well as for performing the intra-row weeding. So whenever we perform the inter-row weeding by the weeders, again we have to perform the intra-row weeds by manually. So there we can effectively use this particular weeder. And another thing is that in the mechanization level, that we know that the farmers are using the different kinds of the sprayers for application of the herbicide. But usually farmers, what they do, they never, because of the limitation of the availability of the sources as well as completion of the covering of the larger areas, they use jet type nozzle and application of the herbicide. So in the video, we could able to see that how the farmers is using the jet type nozzles and is performing the application of pre-emergence herbicide. Because of that, it will be very difficult to obtain the uniform applications of the herbicide, as well as there may be the chances of escaping of the patches will be there, as well as multiple overlapping of the application of herbicide will be there. So there will be uneven application, unevenity will be there. There is no uniformity from these kinds of application will be there. To overcome this one, to give proper solution to the farmers, we try to standardize some of the spraying techniques, that giving some operational, procedures. That, for example, instead of using with the single nozzle, go with the multiple nozzle, like multi-nozzle boom like structure. Go with particular holding it. That is holding of the particular nozzle from 50 centimeter above the targeted area, and perform the spraying operations with the proper discharge rate of the nozzle with the proper speed, so that whatever the area which you are covering, uneven swinging the lands, whatever you are covering, it can be easily covered and uniformly the herbicide can be applied. So we try to develop this, we try to standardize the technique also. We did that. We recommended, instead of going with a single nozzle, go for the multi-nozzle boom structure. By that, we could able to be increase our operational field capacity from 58 to 100%. We could able to be increased, and we reduce the operational drudgery as well as cost by up to 50%. Then another thing is that we have whenever we sow the crop, after that within the 3 days we have to apply. If we are using the pre-emergence herbicide, so we should apply the pre-emergence herbicide within 3 days after sowing. So there we are going now in existing practice. We are going for the 2 phases. First one is sowing the crop. After that, we are going for application of the pre-emergence. Nowadays, some kinds of mechanism which are coming that along with the seed drill, that pre-emergent service application system which coming. By using of that one, we could able to be perform the both operations simultaneously. And so for that, we try to develop some kind of sensor-based portable type pre-emergent service applicator, which can be easily mounted on the existing seedlings and planters. Whatever the machines which are coming or which are newly coming, the farmers has to purchase a new machine. What we did here, we developed a portable system so that it can be easily mounted on the existing sprayers, existing planters and seeders. And another thing is that whenever the farmers are applying or using the multi-nozzles also, so he has to constantly hold the boom and uniformly maintain the particular operation holding it. So here it is also that is causing operational fatigue to the operator. To overcome those, we developed some kind of mechanism that here this is the existing practice. Existing practice in the sense we have the tractor operated boom sprayer is there. It will be stand in one particular position by using the spray hose pipe and the boom nozzle boom. The operator is holding and he has to walk through entire field. In the video, we could able to see that he is totally exposed to the applied herbicide as well as so it is causing more fatigue on the operator because he has constantly hold that particular boom throughout the field. And in this particular condition situation, here operator is holding the boom and he has to perform the spraying operations. Because of constantly holding the that particular boom, that is causing the unbalance. As that causing the unbalance as well as because of that is getting the wrist pain and as well as that is uneven application of the herbicide also. In the video we could able to see. So to overcome this problem, we try to develop that is spray boom hold attachment for tractor operated sprayer as well as for the knapsack sprayer. So this is the just attachment we developed. We developed some kind of wheel type structure. By using of the wheel type structure, that entire nozzle boom can be easily placed on that particular wheel and operation can be performed. It can be easily mounted like this. So this is the practical testing of the particular measures. We just used under different condition also. It is very working very fine. Only the operator is just need to just push or pull that particular entire unit. No need to just hold it and walk through the entire field. Because of this, that is almost 50% of the operational drudgery has been reduced. And this is the one type of another type of the structure which we have developed for knapsack sprayer. That is placing of the entire boom behind the operator. So whatever the chemical which is applying behind the operator. So operator no need to hold the boom in hand as well as is not directly exposing to the applied chemicals. This is the one of the video which is testing under the different colors. And this is the field tested under different feeding attachments. And we have ergonomically tested also in the conventional existing spraying system that is holding up to that boom, spray boom, almost 5 kgs of load which is coming on the operator. He has to constantly hold it and has to walk throughout the field. If we compare with that developed system, the operator is just getting only around up to 3.2 kgs of force. That too, no need to hold it. He just has to push it or pull it, which is if we the economical perspective, if we see that pushing and pulling force is recommended instead of holding the weight. So ergonomically it is suitable also, as well as our efficiency has been reduced. And I have observed the physiological response of the subject by using of different kinds of attachment. So what I'm getting is that is ergonomically recommended, that in the sense operator physiologically responding within the recommended limit. And we have tested for the different parameters also with a different load, that is using of the different amount of water like 5 liter, 10 liter, 15 liter and 20 liter. With a developed attachment, we could able to be used up to 20 liter without having any more operator fatigue. We could able to be used very easily. But if we won't use that particular developed attachment, operator could only use up to 15 liters of spray volume. This technology has been applied for patent, and one of the technology has been get commercialized also. And with addition to that, we try to develop the some kind of tricycle boom sprayer, which is best suited to the small and marginal farmers. Instead of using with the tractor operated sprayer, we try to develop here. It is having the application width of almost 6 meters, which is equal to equal to the tractor operated spraying system. It requires just 2 man-hour. Just I'm telling that in hours, just 2 man-hours per hectare. If we compare that one with the existing practices, we almost require 3 to 4% per hectare. So there it is very, very effective. And with a cost of around 10 to 11,000 rupees, we could able to develop. And we have tested under different crops also. It is very working very excellent. And we upgraded the system into the solar operated system also. So we just installed the solar panel. The solar panel, it could effectively can be. And we try to optimize that particular spraying system into this smaller quantity also. We tested under the crop different with a residue load and with a different cropping system also. So it is working very well with very good weed control efficiency we achieved from this one, and very with uniform spray uniformity. And we tested with the different nozzle orientation angle under different residue condition for the penetration to study the penetration of the spray particles. At 45-degree orientation angle, the spray penetration was very good, and we almost get very good weed control efficiency. Then, with addition to that, we try to develop the standard operating procedure for herbicide application through drone. We have used a small category drone having the 10 liters of the capacity, and we have tested for the pre-emergence herbicide as well as the post-emergence herbicide and different crops like rice, wheat, green gram, and pea, and even mustard also. These are all some of the herbicides which we have tested for SOP. That the SOP we are developing and analyzing the data, and very soon it is going to become. This is some of the highlights which we observed during our experiment. But if we operate the particular drone at 1.5 meter height with very low wind speed, that is 0.56 meter per second, our drift. One of the major issue in the drone-based spraying system is that is the drift, because of the wind velocity as well as the upward thrust. We are observing the turbulence of the spray droplet as well as the drifting of the spray applied spray is there. So if we operate that is 1.5 meter height with the 0.56 at 0.56 wind speed, so drift is very less. And this is for the application of the pre-emergence herbicide. If it is for the post-emergence herbicide and all, up to 2.5 meter operational height can be recommended. And we could able to save from 89 to 92% of the water volume compared to the conventional system. And labor and time, we could able to say around 69 to 88.5% of the labors and the time we could able to be saved by using of the drones. And by using of the drones during rainy season, if it is the window period is very small, where the drone can be effectively used for application of the herbicide and all. Then another thing is that mechanized weed management with the integration of the sensor. Why the integration of the sensor is that we know that is the appearances of the weeds within the field, it is not uniform. We have the spatial variability and heterogeneity, there will be patches will be there. Simply application of any input like herbicide or performing the weeding operations without considering the spatial variability, there will be a huge losses will be there. To overcome that, there is a site-specific management of the weed is very much needed. To do that, to obtain that, so that is integration of artificial intelligence as well as the sensor. So it will solve the purpose and very precise application of input can be done, and we could able to achieve very good weed control efficiency. So why it is that a site-specific management it is needed is that if we follow the site-specific management, that spatial variability can be avoided. We could able to save around 50 to 80% of the herbicide, and 30 to 90% of the operational cost we could able to be saved. With addition to that, that controlling of that intra-row weeds. For example, in a conventional weeding system, when we are performing the weeding operations, only inter-row is performed. Very few options are there to perform the intra-row, but it is not that much effective. But using of this kind of sensor-based system, we could able to perform the intra-row weeding also, along with the inter-row weeding system. So one major thing in the sensor-based system is that we have to identify the weeds, then we have to perform the differentiate between the crops and weed, then we have to perform the weed control option. To do that, we have two approaches, that is proximal sensing and what is that the airborne sensing. Proximal sensing is a sense using of the ground-based, sensor system like robots with a camera or with the ultrasonic sensor and all. Identify the weeds, that is proximal sensing. Another thing is that is airborne sensing. Airborne sensing is using of the aerial vehicles or satellite imagery remote sensing system. So development of the weed map, identification of the weeds and development of the weed map, it is the airborne sensing. To do that, we use different kinds of the sensor like optimal sensor. In the optimal sensor, we use the camera, multispectral camera, hyperspectral camera, or even the VGA camera also. We use the photoelectric sensor or sonar sensor, that is ultrasonic sensor, and that is detection of the objective. So these are all the some of the sensor which we use for identification of the weeds. On the basis of that, we have two systems. That is the machine vision based system. That is machine vision system in the sense using of the optical sensor to taking the images, identification of the weeds, and performing the weeding operations. That is a machine vision system. And another one is that is photoelectric or sonar sensor system in the sense identification of the object, that is emitting a signal, that signal which is hitting to the object and coming back. By receiving that particular signal, detecting whether the object is there or not. Using that particular principle, we are identifying the weeds and crop, then performing the weeding operations or application of the herbicide. That is the another system. This is just the conceptual view of the machine vision based system, that is taking a picture, identification, making a grid and then taking a decision whether to apply the herbicide or not. This is just the concept. On the basis of this concept, we have in machine vision system two approaches. That is based upon the weed biomass or weed density, that is using of the variable rate herbicide application system, that is considering the vegetative indices of the particular weeds and altering the dose of the herbicide application. That is the one thing will be there, which is coming under the real-time approach. In within that real-time approach, we have that is identification of the weed and spot application of the herbicide. That is the which comes under the real-time approaches. And another thing is that is the development of the weed identification map. That is first we develop the weed map by using of the remote sensing system. We develop weed map. With addition to that weed map, we develop a prescription map. That is in particular spot that particular weeds are there, in which quantity the biomass is there, how we have to alter the doses, or where we have to apply the herbicide. Like that, we develop a prescription map. Then we perform the operations. This is both the map based approach and the real time based approach. This is the GPS based system which is used for the map based approaches. This is just a schematic view how it will be work. I'm just showing by using the remote sensing and all. So we will identify the spot, then we'll make a grid, then identification of the patches within the field, then we will develop a prescription map. Then after development of that prescription map, then we will feed into the system. That feed the system automatically does where it has to be applied the herbicide. This is the just one of the study which has been conducted. The first green color which is showing it is the weed map with that particular weed map. The second picture which is showing is that is the herbicide rate prescribed map with based upon that particular weed density, that this much of herbicide should be applied. This is the prescribed map. In the third one is that based upon that prescribed map, how the machine has been performed. By using of this mechanism, we could able to achieve almost 30% of reduction in the herbicide application system compared to the conventional method. This is the environmental friendly also as well as cost friendly also. Then the real-time approach, as I said, in the real-time approach, that is a spot application and variable rate technology is there. In variable rate technology, we use the vegetative indices of the plant, and accordingly we apply the herbicide. And but it has the limitation that growth of the crop may affect the performance of the machine. So there is that one limitation is there. On the basis of that particular the concept from IIT Kharagpur also, I was a part of this particular system. So we try to develop based upon the NDVI values, and we try to alter the variable rate herbicide application system by using of that almost 57% of the herbicide we could able to be reduced, and it was very working fine. The only thing was that light intensity disturbances from the light intensity was the problem. With proper precautions, we could able to achieve very good application efficiency. And the other thing is that the spot application of herbicide or removal of the weeds, the same using of the same concept, that is identification of the weeds and executing the whether to apply the herbicide or whether to remove the weeds. By using of treatment, up to 90% herbicide can be saved, and up to, as I said, also up to 80% of the operational costs can also be reduced, and intra-row weeding can be effectively used. So these are all some of the systems which using of that particular concept can be effectively used for performing of the weeding operations as well as application of the herbicide. And the first one is that the robotic based weeder is there. The second one is that electric weeder is there, using by passing of electricity, killing of the particular cells of the plant. And third one is a laser weeder is there, and spot application of herbicide is also there by using of the weed identification process. And here one work we also did at IIT Kharagpur, that identification using of the ultrasonic sensor, identification of the plant, and assuming the plant height is having above the weeds, and performing the weeding operations. For this technology, we got patent also, and we perform under the field condition also up to 87% with proper matching with the operational speed of the tractor. We could able to achieve the weeding efficiency. That mechanical weeding efficiency was so high, but the only thing is that that height of the weed should be less than that particular crop. So on the basis of that concept, we did it, and it was working fine also. In the previous, I said that some of the existing seedless and planters are coming along with the pre-emergent herbicide application system. The farmers who is already having the seedless or planters, if we tell them to purchase the new sowing cum herbicide application system, it will be very difficult for them. So to avoid that, to give the solution to them, we just developed a portable system. Portable system, the cost of around 4,000 to 5,000 rupees we just developed. It is just need to be installed on the existing seedless and planters. And by using that, that automatically it will cut off whenever the sowing operation is done. Then only the herbicide will be applied. When sowing operation is not happening, automatically it will get the spraying get off. That particular mechanism which we used, and it was working very well. We just mounted on the existing conventional seed drill. While sowing the operations, it is applying the herbicide. When that particular sowing operations stop, automatically the spraying is also got stopped. I think it got stuck. We mounted the same. No, am I audible?
Yes, continue now, sir.
Okay.
We'll continue.
We mounted the same mechanism. Actually, there is a disturbance in with my internet connectivity, which got stuck. Okay. We mounted the same portable mechanism system to the existing data planter also. In that condition, it was working very well. Almost 22% of the herbicide which would be able to be reduced, and operational cost. We combined both operations, that is sowing operations as well as application of the pre-emergence herbicide. We combined both the operations and we perform. By that also we save time as well as around 1,000 rupees of operation cost also we could able to save. And the entire system we developed with the cost of just 5,000 rupees, which can be easily mounted to the all the existing and seed drills and planters. There is no need to purchase a new seed drill, some herbicide application system. Then at the end, this is just the conclusion that the site-specific management of the weed and precise application of the herbicide is the need of the hour. And in India, we have large portions of the small and marginal farmers. We should develop the technology. We should be mainly focused on the small and marginal farmers, and we should develop the ergo refined, low-cost technologies which are suitable to the Indian farmers as well as it may be the developing nations. And we should develop the technology, sensor-based, economically viable technology should be afforded by the Indian farmers. Otherwise, if you are developing some kinds of the technology, it is having very high initial cost, or it is not suitable to the Indian topography, then it will be very difficult. So we should concentrate to our conditions, then we need to develop. And drone-based application system, it is the very emerging future technology, but the standard operating procedure needs to be developed so that the drift problem may reduce, may cause the phytotoxicity effectively adjacent crop. So these are all the over the presentation, and thank you. If any questions are there, I will be happy to answer.
Thank you so much, Dr. Saab. So
Thank you.
thank you for your insightful presentation. Now I requested to all the participants, if they have any question, they can raise their hand or put your question on the question and answer box. Few questions are already there, so I will ask that question, and sir, if possible, you can give the answer. Okay. So one question by anonymous attendee, they have asked, how sensor will differentiate between the crop and weed, like wheat and phalaris minor, or different weed species among diverse weed flora? On what basis the herbicide will be selected to manage the weeds?
This identification of the crop and weed, like wheat and phalaris mineral at the initial stage is very difficult because it shows the same, wheat and this one, phalaris mineral, wheat and weed characteristics. Selecting the spectral signature of the particular weed using the different kinds of the sensor. For example, the physical appearances, it may look similar, but using of the different alternative the methodology, like spectral signature, that particular spectral signature of the wheat may be different and the spectral signature of the phalaris minor may be different. By using of the hyperspectral imaging sensors, we can differentiate the crop, and based upon that we could able to be develop a weed map or identification of the particular crop and weed can be done. And the second thing is that on what basis the herbicide will be selected. On what basis, in the sense I did not get it. In the sense, there is a recommended herbicides will be there for a particular crop, and you mean to say is that after identification of the weeds you are telling, or say as a whole you are telling? That I'm just getting confused.
On what basis herbicide will be selected to manage the weeds?
In the sense, whatever the recommended herbicide is there, so we are just using that application of, for example, it is having the resistance, then that is the non-selective herbicide may be used. That is by properly protecting the crop. That can be done, but it is not having the resistance, herbicide resistance. Then normal recommended herbicide can be used. That is not a problem. So that will be there. Then how to control the weeds in conservation agriculture, as residues leave over the surface, and how mechanized weeding could remove the weeds. Using of the mechanized weeders in the conservation agriculture, I don't think so, because as one of the principle is that in conservation agriculture we should not disturb the soil. That is there. Instead of that, in the mechanical weeder we can go with the we showed that laser weeder, but of course that is the problem of sparking, and that because of the residue there may be the chances of flame is also there. But using of microwave weeder, there is another weeder is there, microwave weeder. We can use that under conservation agriculture if it is appears from the above the crop residue. And even there is some study shows that using of the microwave weeder, we can kill the weed seed which is there in the soil also. That is there, that we can use conservation agriculture.
Okay. Another question is there, sir. For spraying height of drone.
1.5 meter. This is for the herbicide application more than 1.5 meter only, 1.5 to 2.5 meter only. That for the reduction of the drift, which I have said, it is not 1.5 meter is not suitable to all kinds of herbicide. Like for the pre-emergence herbicide, 1.5 meter is there. I said for the post-emergence herbicide also up to 2.5 meter we can use. But going beyond the 2.5 or 3 meter, then if it is little wind is also there, more than 3 meter per second also, automatically the drift problem is there. So we should be careful if it is a wind speed. If we have very less wind speed, then it is recommended. If it is wind speed is little higher, again we have to increase our rate from 1.5 meter to 2.5 meter. But we should be very much careful while selecting the height, because we should know our local condition, wind speed condition. Then only we should select. Blindly we can't go with a proper rate also. That is there. Flame weeding, it will not affect the crop if they are also in the initial stage. No, it is not going to be. The flame temperature around 400 to 500 degrees centigrade will be the flame temperature. With the proper precautions, if we perform that, It can be done. Some studies are there performing the inter-row flaming is also has been done by protecting the crop rows. It is there, but you should use the proper insulating material. By using that particular insulating material, you can do. That is not a problem. That is there. Mulberry crop and their practicing 2 feet, 3 feet, facing most stakeholders or marginal farmers hardly having which kind of weeding machines. As I suggested you, sir, for small and marginal farmers, if you go with the brush cutter with the weeding, rotary weeding attachments are coming, sir. If you go with, you can, sir. It is very suitable. Around hardly you will get 10 to 12,000 rupees. You will get that particular, brush cutter with a weeding attachment. Very effectively can be used. With a different kind of attachment, you can use for wetland condition also, sir. That is there. Another question is, can you suggest any low-cost manual weeder which is economical and be usable to women farmers workers in the crop? That is spin wheel. That is one weeder is there. It will hardly come around 1,200 rupees to 1,200 rupees to 1,500 rupees. That is twin wheel woes are there. Some manual woes are there. Any kind of hose which is having V-type strips are there. That cutting element that is there. You can use it, madam. Even the hand grubber also. Around 700 to 800 rupees it will come. If they don't have the problem in the standing position, they can perform the weeding operation. That hand grubber, long handle and grubbers are there. That also can be used. Usage of non-selective herbicide is possible with the sensors. Yes, non-selective herbicide with possible with the sensor. By protecting, using the proper protection, you can use the non-selective herbicide. That is not a problem. Is a technology available in India? Yes, sir. Technology which is already available in India. But the question is that adaptability of that particular technology. One of the technology, if you are interested, that is X machine. One Hyderabad based one company is there. That hardly 2 lakh rupees. That small particular unit which is coming. It is very good. Even I have practically seen also their performance. They're working very well. You can adapt that one.
Sir, we will take few questions more. One hand raised by the Kavita Sagar. So I request to unmute her and she will ask the question. Kavita?
Yes, sir.
Okay.
I'm audible?
Yes, yes.
Yeah, thank you. Thanks, sir. Thank you. Good afternoon. Sir, first of all, I want to thank you for very interesting, presentation along some videos as well. So my common question is, whatever the method we use for controlling the weeds, whether it is biological, cultural, mechanical, or any other methods. So one common concern regarding the poaceae members, especially the grasses, whether we use flame weeder or whether we use the sprayers to spray the herbicides, either through drones or through jet sprayers also. But commonly, they will be affecting, the herbicides will be affecting only the upper ground parts of the plants. I mean to say only the leaves. The roots of the grasses will be deeply buried. So, so my thing is whether any sort of mechanical method would be so much effective in controlling, especially the weeds, so especially the grasses. What is your input on this?
Grasses in the sense, I think you are talking about the Cyanidon as well as that cypress.
Common grasses, sir. Common grasses in the crop fields. Yeah.
If we are using the non-selective herbicide also, that might work. If it is having the nodules like structure, it is not going to be happen. That will be effectively answered by, I think, some of my agronomist friends. If it is having the nodules, what kind of the herbicide can be used? Under the mechanical management, we can control that, but we should go with that first we have to be expose all the nodules to the upper side, then we should sun dry it, then again if it is reappears, then again we have to go with the like stale seed, it build techniques. Some of the techniques are there. Using that, we can control that by mechanically. So that can be done. But okay. It is depending upon the weed type of the grass which are there. If it is Chelon Dactylandon is there, that is breaking up again that particular grasses, again it will again reappear. Again it will come. Then again we have to go 3 to 4 times of the mechanical weeding. We have to expose all the that particular part of the upper side. We have to dry it, and again if it is reappears, then we have to go for the stale seed bed. Same procedure again we have to do. We can control it by the mechanical weeding.
Okay, but as per my information goes, these grasses, especially the poaceae members, which are very aggressive and very notorious weeds, and they are stubborn also. the management or the control measures, whatever the any type of control measures, they won't be so much effective in cases of the POAC members. So using the flame weeder,
Again,
uh,
if you use the flame weeder, if it is having the nodules, it is below the ground. Again, it is not going to solve your purpose, madam.
so
You have
yeah,
to go
solve
with
the
the
purpose.
tilling.
Yeah, yeah,
You
yes,
have to go with the tilling of the soil. You have to go the tilling
yes,
of the soil, and we have to expose those particular nodules and all. Then again, we have to kill the particular grasses. Then only it can be
yeah,
done.
yes, sir, yes, yes. Thank you so much.
Okay, another hand raised by the Anita Mahapatra. So she can ask her question. Anita. Anita Mahapatra, you are there? Gyananji, you can unmute her.
सर परमिटेड है बट
Okay.
नहीं दे रहा है.
So last question we will take, and remaining question, if the participant have their questions, so you can put in chat box, and we will try to give the answer, or later on we will provide the answer. So one question I have seen here: how the attachment works for both the seed drill and sprayer in terms of power. So this question raised by Hari Singh. So sir, can you give the
Attachment
answer?
is that particular attachment, that is portable
Seed,
type.
seed come
Portable
third.
type images. Yes, yes. Portable type herbicide applicator system which we have developed. That is operated by the battery. There will be separate batteries there. That is 12-volt battery, 9 ampere 12-volt battery we just used. By that it is operating. We simply use one relay switch with the battery and with a microcontroller. That is by the sensor we are just getting the signal. The object is there or not. On the basis of that we are just using it. Even we can use the power. We can use the power of the tractor also. And again, using a tractor is having the high voltage. Again, to reduce that particular voltage, to use the microcontroller. Again, it will take extra part. So that's why instead of that, we just use simple UPS battery.
Okay. So sir, again, thank you so much. And